Mutubura.
Good day, class. My name is Bashir Ibrahim, and today's class I'll be, taking you one of the important topic in econometry, and it's called coefficient of determination, or sometimes we call it R square, or sometimes we call it R square or coefficient of determination. So, is R square or coefficient of determination is, the proportion or the percentage of dependent variable being explained by all the independent variable. That is, the variation in explained variable being explained by all the explanatory variable, or probably a simple independent variable if you consider the simple regression analysis. But if it is multiple regression analysis, we say it's a percentage in explained variable being explained by all the explanatory variable, and it's also called a goodness of fit. It is called a goodness of fit, which is also used to determine how fit your model is. It is used to determine how fit our model is, and to determine the R square, we have different ways of deriving the R square. And I'm going to take us through like 4 or 5 methods of how we can derive the R square. So we can recall that we have this is equal to beta naught plus beta 1 x error term, right? When I try to prove the simple linear regression analysis, then we call this to be population regression function, right? And we have the sample, which is the one with cap. So we call this beta naught cap 1 cap f cap error term, right? So we call it to be sample regression analysis. So you can also recall that this is known as total variation. Total variation, and this is known as explained variation. Why we call this error term to be unexplained variation? Right? We call this to be unexplained variation. And also the small y in econometry is the same thing as y minus y bar. It is the same thing as y minus y bar. So we can rewrite this to be small y squared to be summation of y minus y bar squared, and the estimated square will be y cap minus y bar square, right? Why the error term? The error term, so we can use U, we can use E, it's the same thing. Why the error term is the same thing like y minus y cap minus y cap square, right? So we can use this to determine the R square. And also we say that the TSS is the same thing as total sum of square. Total sum of square. And ESS is known as estimated sum of square, right? While the RSS is known as residual sum of square. Residual sum of what? Of square. Class, we can use the information we have on the board to derive what the coefficient of determination is all about, or R square. Now let's start. Now, method 1. To derive the R square using this method, then we say that y and y bar square to the same thing as total will be equal to the estimated summation of y cap minus y bar square plus residual to this y minus y cap square. right? So to determine the R square, you divide both sides by the total, right? Divide both sides by this, right? So in doing this, we have this divided by this, and it will be equal to right? So you can see that this and this are the same, right? So this we cancel this, we have 1, and it will be equal to this. Right, so what we have here is the same thing as R squared. We can use the formula that we have here to derive the R squared, which means that this is equal to what? R squared. Right, is equal to R squared. So if this is equal to R squared, I can write this formula to be 1 is equal to R squared plus summation of y minus y cap squared divided by y minus y dash squared, right? So to determine the R squared here, so we can say that the R squared will now be 1 minus y minus y cap squared all over y minus y bar class. If you either use this or you use this, you must get the same thing. For coefficient of determination or the R squared, this and this, you will get the same answer. And this is method 1. So for method 2 class, so for method 2, we can also use the TXS, right? So I can also say TXS is equal to ESS. We've explained what this is all about. RSS. Now the TSS is same thing as total sum of square, and is equal to the estimated sum of square and plus residual sum of square, right? So to get the R square here, divide all by TSS, right? So divide by TSS, right? So we have TSS divided by TSS will be equal to ESS divided by TSS, right? Plus RSS divided by TSS. So also, right? So this will be 1, right? This will be 1, right? So we have 1 to be equal to ESS divided by TSS plus RSS divided by TSS. So ESS divided by TSS is also, the same thing as R squared, right? So we can use ESS, that is estimated sum of square divided by total sum of square, to get the R squared. So this R squared is equal to this divided by this, right? Or we can rewrite this to be 1 is equal to R squared plus this, right? So to make R squared solve the formula, right, we can say that the R squared will be 1 minus RSS divided by TSS. So should I use this? Should I use this or use this? You are expected to get the same thing. You are expected to get the same thing, class, right? So method 3 now.